Welcome to SDMX. SDMX stands for Statistical Data and Metadata Exchange. After watching this video, you will know why and how SDMX is useful for you in the exchange and processing of statistical data. Let's start with something specific. Communication. Using the same language allows working more efficiently. That is why we need a lingua franca when we want to speak to each other. This saves us cost of interpretation and helps decreasing errors in exchange of ideas. Here is the parallel with SDMX. At the office, we also use a variety of file formats. Now SDMX comes into play, providing a common language for data and metadata exchange, a common model for statistical data, and a potential for simplifying our work. A second example, mobile phone chargers. Having different types of chargers with different plugs is unpractical, costly, and wasteful. Today, manufacturers have agreed to use a single type of plug. In statistics, we also don't want different data models and transmission formats, leading to a variety of expensive tools and time-consuming conversions. SDMX standardizes the way data are organized and exchanged and provides international guidelines on how to shape the data. Just like USB is a standard used for enabling communication between connected devices, SDMX is an ISO standard allowing data to be transmitted, understood, and operated by software according to a set of common rules. SDMX allows developing standard tools that can be used by all statistical organizations. For instance, the SDMX reference infrastructure created by Eurostat to expose statistical data to the external world using SDMX standards and web services. SDMX organizes statistical data to support search and discovery, also linking data to relevant explanatory information called metadata. Why SDMX? The Internet changed the way people exchange information. SDMX changes the way statisticians exchange and process data. The Internet offers modern technologies. SDMX uses them for activities that statisticians do every day, to describe, share, and relate data and manage statistical processes. Finally, statistics can be published in a way that conveys the full meaning and context, also helping people to compare, interpret, and understand the data. SDMX provides, we would say is, the best available comprehensive framework supporting the creation of automated tools that operate the data, populate websites, or exchange and visualize data. We believe that today, organizing data and metadata into SDMX structures is the best way to organize your statistical environment. So, SDMX is a logical model to describe statistical data, which also provides guidelines on how to structure the content. A standard for automated communication from machine to machine. A technology supporting standardized IT and methodological tools that can be used by all involved in the data exchange and processing. In order to take advantage of all this, statisticians agree to use a common description of data. The common data description is then used as the parameters driving the exchange and processing. And finally, the data descriptions are made available to everybody so that all understand and can use the data. That is what SDMX provides and enables. SDMX does not introduce any new concept to statisticians. It just provides a framework for what statisticians already do. SDMX provides a way to describe the structure of the dataset, called Data Structure Definition, DSD. The DSD can be seen as a logical container for a specific set of data. The definition of the structure ensures that data in the dataset conform to predefined statistical requirements, for example, using correct concepts, codes, and formats. The same technique can be used to exchange information about the quality of the data or the statistical methodology. Now we have a common and simple way to describe, exchange, and process data and metadata automatically. What does SDMX need for describing a statistical table? First of all, we need to identify a set of statistical concepts. Let's imagine we have to create a DSD for tourism statistics. Take a simplified table. 3 tourism topics over 4 periods. We can identify the following statistical concepts: frequency, in this case annual, country, tourism topic, time period. The observation value, which is the actual single figure, the observation status, defined by footnotes such as estimated or provisional. Frequency, country, tourism topic, and period are required to identify the statistics. They act as dimensions. The observation status qualifies figures as an attribute at the observation level. The observation value, the actual figure, is what we call measure. So, concepts play different roles in a data structure definition: dimension, attribute, or measure, to define the statistical data. The result is a formal definition of the corresponding data structure. Our DSD, with all the structural metadata of the table, is ready. Now, after having defined the structure, we describe the exchange process. Let's say that Eurostat has to send a tourism table to an agency, and that, according to the organization scheme, Eurostat has the role of maintaining the objects related to the table in question. SDMX incorporates the idea of service level agreement by defining a provision agreement which describes the way data should be provided. Here, Eurostat is the data provider. The provision agreement might say that the table should be provided before the end of June according to a specific DSD. To enable general access and ease of use, the information on the data structure and on where and how the data can be found is stored in an online resource, the SDMX registry. We have defined the data structure and the exchange process. We have achieved what SDMX calls compliance. These are the steps achieved so far. Preparation. Statisticians from the organizations involved in the data exchange describe the data and the different data flows, data sets, and provision agreements. Compliance. We created all the necessary objects in accordance with the SDMX standard. Next, we put all this into practice. Implementation. Standard software is installed and parameterized to use the DSD and the other SDMX objects. The exchange process is set up and tested. Production, when the data and metadata exchange is carried out according to SDMX specifications. So, what did we achieve? We describe data, metadata, and the exchange process in a standard way. The process is automated. We use commonly available tools and web services. The essence of SDMX is in the corporate benefits achieved through standardization. By using SDMX, we managed to integrate a statistical process reusing the same IT infrastructure, concepts and codes for several domains. We improved interoperability with other applications and other organizations. In one word, we moved from a local to a global optimum. SDMX is sponsored by 7 international organizations since 2001. If you want to know more about it, look at sdmx.org, which provides the technical standard and guidelines and also links to other resources, such as the SDMX info space and self-learning tutorials on specific topics.